unit down there, you get closer to the highway, and then right in the center part is the Rush Lake granite. And it initially was mapped as part of the Mount Scott. Merritt would have included it as that. Some of Charles's work includes it as Facies B, recognized as something different, but Mount Scott-like. It's not that different from the Mount Scott, except it doesn't have the round ovoids, it doesn't have the mafic enclaves. I kicked it out in my mapping and said, well, I think it's something different. It does have its own unique geochemical signature, but it does seem to be chemically related to the Mount Scott and to the Medicine Park. So in your guidebooks, you have this paper about the Mount Scott Pluton, or an intrusive complex, probably is the better word for it. But a series of granites coming in at the same horizon that are cogenetic, that have developed deeper down and released from a common chamber, if you will, that have come in at this horizon. That's the thinking behind it. And it's not that different from how most volcano petrologists view volcanic products, in the sense that lava flows each point to heredity that goes back to, you know, a single event or multiple events deeper down. So that's the thinking behind it, is that we actually have this and then one other granite body out in the central part, the Saddle Mountain granite, that are all related genetically through small amounts of fractionation, nothing to really get excited about, but small amounts of fractionation and a difference in timing that brings them to the surface. And that difference in timing is actually kind of interesting from a heat budget point of view, because my thinking based on the contacts is that the Rush Lake and the Medicine Park come in first and really pre-warm this area of the crust ahead of time, and actually lead to the formation of these rounded feldspars and other features that you see in the Mount Scott granite. The rounded feldspars, we think, are the result of decompression, resorption of the feldspar crystals on their way up. It takes a certain degree of depressurization combined with changes in heat to get that phenomenon. So that's the thinking behind them. They are technically what you'd call Rapakivi feldspars. Some of them have plagioclase mantles, some of them do not. But they're intermediate, sodic potassic feldspars verging on highly potassic feldspars that are mantled. Some of them are mantled with this plagioclase, sodic plagioclase albitic rim around them. All right, so we've got those two granite bodies there. We've got Lake Elmer Thomas directly behind me, a much smaller reservoir. And the Lake Elmer Thomas Dam stop, which is number 4 in your book, but will be the one after the next one on our trip today, is hidden from us, but it's down in these little low-rounded hills down here. So you'll see that area later. It's more Mount Scott granite right there on the far eastern side of Lake Elmer Thomas. It's a quarry, so you get to see fresh exposures of it. And diabase dikes intruding in there as well. Again, not as stunning as what we saw yesterday in terms of number, but there's some unique features that we'll talk about when we get there. Beyond Lake Elmer Thomas, rounded hills of Carlton Rhyolite, the Fort Sill section of the Carlton Rhyolite. So you can see it there, and I'm going to turn it over to Richard because he'll want to talk about the Fort Sill section.
Can I ask a question?
Yes.
Isotope. So one possibility is you generate these granites by melting up the mesoproterozoic basement.
Okay.
But the isotopes tell you something. What do the isotopes tell you?
The isotopes tell you that you're melting very primitive rocks, if I recall correctly.
So sodium isotopes of...
they're all positive, right? I'm trying to think of...
epsilon, neodymium.
Yeah, neodymium is all positive. They're not melted crust.
Yeah.
How positive are they? You know?
3.5.
Plus 3.
Yeah, or 4, something like that.
You said some of them are Rapakivi and others are not.
Well, Rapakivi, as it turns out, if you dig into the literature, can be applied to any rounded feldspar. Although traditionally, when we talk about it, we like to talk about it as a mantled feldspar.
Albite on feldspar.
Yeah,
Rapakivi actually means rotten.
rotten stone and finish. So.
Plagioclase would be on the outside.
Sorry?
Alkali feldspar inside, plagioclase outside.
On the outside.
Right.
There are examples of that. There are also examples in this body that lack the plagioclase rim. And it's a geographical distribution. Some have the plagioclase and plagioclase that occurs in the matrix. Some do not. You don't really pick it up on the geochemistry. There's no difference in the alkalis and the ratio to the aluminum and silicon.
Textural.
It's a textural phenomenon, but you do see it. I've used the word, ovoid to talk about these, but I mean, they're all from the same genetic process. They're the result of decompression, resorption of the crystal. The fact that you get a plagioclase on the outside just means you were in plagioclase stability. You had enough calcium to pull, or sodium and calcium to pull it off when you're finally crystallizing the outside rim. But the same process applies to rounding the feldspars whether they have the rim or not.
Can I
So
ask you a general question? Other places in the world, you have studied these rocks. Have you seen other comparable examples of this kind of field relationship? Like Finland, there are some granites like this, I believe.
Oh, yeah.
Mhm.
V-board.
Right. So, what is their origin? What do they propose there, and are they applicable here?
Those are 1,500.
Yeah, they're older. They're Photozoic, Photozoic.
in terms of other,
Tony Ramos said about that.
Right.
I don't remember.
Yeah, Ramos. Yeah.
But
They're A-type.
They're A-type.
Yeah,
yeah, they are
Yeah,
A-types.
the V-board is an A-type.
Yeah.
This is an A-type. Huh?
This is an
Yes.
A-type too.
Yeah.
Does the lack of resorption say something about the possibility that this thing was not water saturated when it ascended?
The lack
Or
of
not the la-
resorption.
the actual resorption. The resorption. Does that say something?
They are water poor as far as we can tell. You don't see a lot of murialytic cavities in this rock, although they're the best examples actually around here.
No pegmatite ever.
No.
They're rare pegmatites. Like we'll see some examples of more coarser grained materials and finer grained materials, athletic materials, microgranites.
Well, what we call pegmatites here is because we're used to looking at the fine grain stuff.
This is true. They're not the stunning thing. But if you go out to the reformatory, you can find more traditional looking.
You get big crystals out there?
Well, the reformatory granite's a lot coarser to begin
I
with.
think of the pegmatites.
The pegmatites have very coarse crystalline
Really?
textures.
I've never seen that.
Yeah, no, they're
Well,
quite
how
stunning.
big? Like a meter?
Well, maybe not that big, but again, it's all relative. But yeah, a few inches for the quartz crystals and maybe half a foot for the feldspars.
You can live with the Arbuckles of the mountain. You can live with these as a pegmatite.
Exactly.
It's all relative.
That's a fair
One other
assumption.
question.